Hello children, how are you all? Welcome to the digital classes. Children, in the last class, we have studied about the types of chemical bonding. Let me first ask you a few questions, children. What is matter? Matter is something which has mass and occupies space. Matter exists in three states: solids, gaseous state and liquid state. And examples of solid state: ice, gaseous state vapors, and liquid state is water. So if you consider solids, how are the molecules present in solids? They are tightly packed, and in liquids the molecules are loosely packed, and in gases the molecules are freely packed. What are these molecules? Have you seen the structure of a water molecule? Children, this is the structure of a water molecule. It has two atoms of hydrogen and one atom of oxygen. So the molecular formula of water is H2O with two atoms of hydrogen and one atom of oxygen. And the bond angle between the two hydrogens is 104.45 degrees. Then how did we come to know about the bond angle? How did we come to know about the bond length? All this we will be studying in the lesson chemical bonding. Children, if you consider the formation of water molecule, we have studied it in the last class. Hydrogen and oxygen, they share electrons with each other and form a covalent bond. So if you look at this picture, hydrogen has one electron. It needs one more electron to attain duplet configuration like helium. And oxygen has 6 valence electrons. It requires 2 more electrons to attain octet configuration like neon. So hydrogen and oxygen, they share one pair of electron each, and this hydrogen also shares one pair of electron each with oxygen, thus forming a water molecule. Two atoms of hydrogen bonded with one single atom of oxygen. Here oxygen is bonded with two atoms of hydrogen. So children, we have studied about the types of covalent bonds in the last class. We have studied when one single pair of electrons are shared between two atoms, then a single bond is formed. Here one pair of electron is shared between hydrogen and oxygen, so there is a single bond present between hydrogen and oxygen. And then what about double bond, children? If two pairs of electrons are shared between two atoms, then a double bond is formed. If you see, this is the structure of carbon dioxide. Here carbon is sharing two pairs of electrons with this oxygen, and it is again sharing two pairs of electrons with this oxygen. Thus it is forming a double bond between carbon and oxygen and one more double bond between this carbon and oxygen. So this is the structure of carbon dioxide. This is double bond which is present between carbon and oxygen. Now we have also seen about triple bond, children. If three pairs of electrons are shared between two atoms, this is one pair, second pair, and this is third pair. So if three pairs of electrons are shared between two nitrogen atoms, then we say that this is a triple bond formed. So children, in the last class we have studied about the types of covalent bonds. Now in this lesson, we will be studying about how are these structures appearing. So as we know that there are three types of orbitals present in an atom. What is an orbital, children? It is the space around the nucleus in an atom where an electron can be found more oftenly, isn't it? So if you see the types of orbitals, we have s orbital, p orbital and d orbital. The shape of s orbital is spherical. It can accommodate two electrons. The shape of p orbital is dumbbell. In p orbital, we have px orbital, py orbital and pz orbital. If the dumbbell lies on x-axis, then we say that is px orbital. And if the dumbbell lies on y-axis, then we say it is py orbital. And if the dumbbell lies on z-axis, then we say it is pz orbital. So children, in valence bond theory, we will be studying about the overlapping of the orbitals, s orbital and p orbital. Okay children? Now, what is the shape of d orbital? It is double. So, we have 5 d orbitals. So, about the overlapping of d orbital we will be studying in the next class. So, let us see the shapes children. S orbital shape is spherical. The sphere lies on x-axis, y-axis and z-axis. Now, p orbital shape is dumbbell. Dumbbell on x-axis px, dumbbell on y-axis py and dumbbell on z-axis, that is pz. And the shape of d orbital, it is double. So, what is this valence bond theory saying? So, children, to describe covalent bonding, a quantum mechanical model called valence bond theory has been suggested. It was suggested by Linus Pauling. And what it is explaining, children? It is saying that a covalent bond is formed between two atoms when two atoms approach each other closely and one atom overlaps its valence orbital. What is this valence orbital, children? As we know that the electrons which are present in the valence shell only participate in the bond formation. So, the orbital in which the valence electron is present is called as valence orbital. So, the valence orbital containing unpaired electron and the valence orbital of the other atom that contains the unpaired electron of opposite spin, they overlap with each other. And then what happens? One orbital has unpair, another orbital has unpaired electron. So, when they overlap with each other, then the pairing of electron takes place. So, the formed pair electrons, due to the overlapping of orbitals, they are attracted by both the atoms. The nucleus of both the atoms, they attract the shared pair of electrons and thus a bond is formed between the two atoms. So, let us see one example, children. Here, do you remember what is the atomic number of hydrogen? It is 1. And do you remember what is the electronic configuration of hydrogen? It is 1s1. That means it has one unpaired electron in 1s orbital. So, when both the hydrogen atoms approach each other to attain a duplet configuration, then we can observe that the unpaired electron of one hydrogen atom which is present in s orbital overlaps with the s orbital of another atom, thus sharing a pair of electron between both the hydrogen atoms. This is the nucleus of one hydrogen atom and this is the nucleus of another hydrogen atom. This is the shared pair of electron and thus the nucleus of one hydrogen atom attracts the pair of electron. Nucleus of the other hydrogen atom also attracts the shared pair of electron, thus forming a single sigma bond. And this sigma bond is formed due to the overlapping of s orbital of one hydrogen atom with s orbital of another hydrogen atom. So, we say it is sigma SS bond. So, children, how is a sigma bond formed? Sigma bond is formed when one orbital of one atom and another orbital of another atom, they overlap with each other along the internuclear axis. Here, the extension of overlapping will be more, and so the sigma bond is called as the strong bond. Look at this picture, children. So, this is a spherical s orbital belonging to one of the hydrogen atom. So, one s atomic orbital of hydrogen atom. When it approaches another hydrogen atom with an unpaired electron present in one s orbital, then the overlap takes place and thus forming a sigma bond. So, sigma bond can form between the two s overlapping orbitals and it is cylindrically symmetrical. So, we have seen the bond formation of hydrogen atom, children, and so according to valence bond theory, hydrogen bond is formed here between the two hydrogen atoms. There is a sigma bond formed because hydrogen bonds formed because one s atomic valence orbital from each hydrogen atom overlaps with each other and forms a sigma SS orbital. So children, sigma bond is also formed between s orbital and p orbital also. So sigma bond has a characterization like head to head overlap is seen, cylindrical symmetry of electron density along the internuclear axis takes place. So it is difficult to break sigma bond. We require a lot of energy to break this sigma bond, and so we call it as a strong bond. So how is the sigma bond formed? It can be formed when two s orbitals overlap with each other. So this type of sigma bond is called as sigma ss bond. And when one s orbital overlaps with another p orbital, then we say a sigma bond is formed due to sp overlap. Now in this case, you can see that a sigma bond is formed due to the overlapping of one p orbital with another p orbital along the internuclear axis, and so we say that this is sigma sp bond. So sigma bonds are characterized by head to head overlap. So the head of one orbital overlaps with the head of another orbital along the internuclear axis. So a cylindrical symmetry of electron density about the internuclear axis takes place. Now there is another type of bond called as pi bond. Now what is this pi bond? Children, as I told you, sigma bond is formed due to the overlapping of the orbitals which are present along the internuclear axis. Then what about the other two orbitals present in p orbital? If the dumbbell lies on z axis, then if this dumbbell is overlapping with another p orbital along the internuclear axis, then a sigma bond is formed. And when py orbitals overlap, and if px orbitals overlap, then they are not going to overlap along the internuclear axis. They are overlapping parallel to the internuclear axis, thus forming a banana bond. And this banana bond is called as a pi bond. So children, why is sigma bond a stronger bond? Because of the greater overlapping. The greater the overlapping of the orbitals that forms the bond, the stronger will be the bond. And so we say that sigma bond is a directional bond. So children, each bonded atom maintains its own atomic orbitals, but the electron pair in the overlapping orbitals is shared by both the atoms which are involved in overlapping. So if two atoms form multiple bond, then what happens? Then two orbitals, when they overlap along the internuclear axis, they form a sigma bond. And after the formation of sigma bond, then the other two orbitals overlap laterally and thus forming a pi bond. And this is weaker than sigma bond. So a sigma bond is formed when two s orbitals overlap, and it is also formed when s and p orbital overlap. So a sigma bond is stronger because the electron pair is shared and is concentrated more between the two nuclei. Here the overlapping is called as end on end or head on end overlapping, and it is along the internuclear axis. So maximum overlapping takes place. So it is stronger bond. But what about the pi bond, children? The pi bond overlap gives a weaker bond. Why? Because it is a lateral overlapping of p orbitals. It is not along the internuclear axis, and so pi bond can be broken easily. So let us see the formation of pi bond, children. How is it formed? It is formed when two orbitals of two different atoms overlap laterally. So two ends are not overlapping, children. The sideways overlapping is taking place, and so the electron density is present above and below the internuclear axis. So it can be separated easily. So we say that pi bond is a weak bond. So this is the internuclear axis, children, and where is the overlapping take place? It is taking place above the internuclear axis and below the internuclear axis, and so the electron density is present on either side of the internuclear axis, and so it is a weaker bond. Now let us see types of covalent bond, children. SS overlap forms a sigma bond. SP overlap also forms a sigma bond. PP orbitals, when they overlap along the internuclear axis, it also forms a sigma bond. Let us see the strength of these sigma bonds. Which bond is a stronger bond? PP bond is stronger than sp bond, and sp bond is stronger than ss bond. Let us see some more examples, children. Chlorine molecule. Do you remember what is the atomic number of chlorine, children? Yes, 17. Let us write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3px2, 3py2 and 3pz1. That means it has one unpaired electron. In which orbital, children? Yes, pz orbital. So it requires one more electron to attain octet configuration. So for the formation, let us write Lewis structure. So chlorine has 7 valence electrons. So when two chlorine atoms to attain octet configuration, they approach each other, share one pair of electron between them, thus forming a single sigma bond between the two chlorine atoms. So this is a Cl2 molecule. Now in this, each chlorine atom has 8 electrons. Count the number of electrons present around the chlorine, children. Yes, there are 8 electrons on each chlorine atom. Thus, it has attained octet configuration after the formation of chlorine molecule, Cl2 molecule. So, let us see how is the p orbital involved in the bond formation. This is 3s2 orbital and this is 3p5 orbital. How are the 3p5 orbitals or electrons arranged in the orbital, children? So, according to Hund's rule, one electron should enter in each orbital first. So, let us write one electron in 3px, then one electron in 3py and one electron in 3pz. Then, fourth electron in 3px, fifth electron in 3py, and we have only 5 electrons. So, we have one unpaired electron here, isn't it, children? So, this unpaired electron is present in 3pz. So, when two chlorine atoms approach each other, the pz orbital of one chlorine atom overlaps with the pz orbital of the other chlorine atom, thus forming a sigma bond. Now, this sigma bond is formed due to the overlapping of the p orbitals, p orbital of one chlorine atom with the p orbital of another chlorine atom. So, we say that it is a sigma pp bond. Look at this another example, children. Fluorine molecule, even it belongs to 7a group. So, it has 7 valence electrons. It requires one more electron. And where is this unpaired electron present? In 2pz orbital. So, 2pz orbital has one unpaired electron. So, when one fluorine atom approaches another fluorine atom, then the unpaired electron present in pz, it combines with the another pz orbital. So, head-on overlap takes place, thus forming a sigma bond due to the overlapping of p orbitals. Now, after the overlapping, the unpaired electron has got its pair and now each fluorine atom, they are sharing 8 electrons. So, this fluorine atom has 8 electrons, even this fluorine atom has 8 electrons. Let us see one more example, children. Oxygen molecule. What is the atomic number of oxygen, children? It is 8. What is electronic configuration of oxygen? 1s2, 2s2, 2px2, 2py1 and 2pz1. That means it has 2 unpaired electrons, one in 2py and another in 2pz. Let us see how is the bond formation taking place. So, let us write down the atomic number of oxygen, 8. So, it has 6 valence electrons. So, we have put 6 dots around the oxygen atom. Now, even this oxygen atom, if you consider, it has 6 valence electrons. And when they approach each other, they share 2 pairs of electrons. Thus, this atom has 8 electrons and even this atom has 8 electrons. When they are sharing 2 pairs of electrons, they form a double bond. Now, actually, where are these electrons present, children? Now, here the electrons are present in p orbitals. So, we have one unpaired electron in 2px and another electron in 2pz. Then, how are we going to see the bond formation? When two oxygen atoms approach each other, then along the internuclear axis, the 2pz orbitals overlap with each other, forming a sigma bond. And if you observe, there is one more unpaired electron along the y-axis, then the 2py orbital of this oxygen atom overlaps with the 2py orbital of another oxygen atom along the sideways, laterally. So here also the sharing of electron is taking place, but sideways overlapping of orbital forms a pi bond. So if you look at this picture, children, along the plane, along the internuclear axis, a sigma bond is formed, and above the internuclear axis and below the internuclear axis, you can see a pi bond formation. So if you look at the diagram, children, this is px orbital overlapping here along the internuclear axis and thus sharing a pair of electrons. So this is a sigma bond, and this is another p orbital which is overlapping with another oxygen atom p orbital along the sideways, lateral overlapping forms a pi bond. So you can draw the diagram of bond formation on a paper like this. You have to write down the electronic configuration and then find out the unpaired electron where it is present and draw the p orbitals and draw the sigma bond formation and pi bond formation. So this is also called as a banana bond. Let us see one more example, children. Nitrogen atom. The atomic number of nitrogen is 7. The electronic configuration is 1s2, 2s2, 2p3. And how are we going to write according to Hund's rule? One electron in each orbital, and then only the pairing takes place. So we are writing it as 2px1, 2py1 and 2pz1. That means it has 3 unpaired electrons. It requires 3 more electrons, and so the bond formation takes place. So let us see the Lewis structure. Nitrogen has 5 valence electrons, and so we are going to put the dots around the nitrogen atoms. It requires 3 more electrons to attain octet configuration. So it is sharing 3 pairs of electrons with another nitrogen atom, thus forming a triple bond, 1, 2, 3. So 3 pairs of electrons are shared between the 2 nitrogen atoms. So where are the unpaired electrons present? One in px, one in py and another in pz. Now all the 3 orbitals are going to overlap. First, the pz orbitals along the internuclear axis will overlap with each other, thus forming a sigma bond. And so after the formation of sigma bond only, the other 2 orbitals will overlap laterally. So if you look at this, this is the py orbital overlapping along above and below the internuclear axis, and this is px orbital overlapping above and below the internuclear axis laterally, forming 2 pi bonds. So along the internuclear axis, this is the sigma bond formed, this is 1 pi bond, and this is another pi bond. So when there are 3 bonds formed, among them one will be sigma bond and the other 2 will be pi bonds. Only one sigma bond will be stronger, other 2 pi bonds will be weaker. Why? Because the sigma bond is formed due to the overlapping of orbitals along the internuclear axis. Maximum extent of overlap takes place, and we can see that head-on or end-on overlap is taking place, and so it is a strong bond. Whereas pi bond, if you see here, it is formed due to the lateral overlapping or sideways overlapping of the orbital. Like a banana bond is formed above and below the internuclear axis. So the other 2 pi bonds are weak bonds. So this is the way there is an attraction between the orbitals. So this is one nitrogen atom and this is another nitrogen atom. When they come closer, you can see the yellow orbitals, they are overlapping along the internuclear axis, and so it is a maximum extent of overlapping take place, thus forming a sigma bond. Whereas other 2 axes, if you look at, here only sideways overlapping, so only the electron cloud is being shared, and so this is a pi bond which is weaker than the sigma bond. So children, in valence bond theory we have studied that when one pair of electron is shared, a sigma bond is formed. So a sigma bond can be formed when 2 orbitals overlap along the internuclear axis. So one s orbital, when it is overlapping with another s orbital along the internuclear axis, then a sigma bond is formed. And when one s orbital overlaps with a p orbital, then along the internuclear axis, then a sigma bond is formed. And even when 2 p orbitals, when they overlap along the internuclear axis, then also a sigma bond is formed. But in a double bond, one is sigma bond and the other one is pi bond. And this pi bond is formed when the sideways overlap of the other two orbitals take place. Lateral overlap of p orbital forms a pi bond. And in a triple bond, one is sigma bond and the other two are pi bonds. So a sigma bond is formed when two orbitals of both the nitrogen atoms we have seen, they overlap with each other along the internuclear axis. And when sideways overlap takes place between the two px orbitals and the two py orbitals, then a pi bond is formed. It is above the internuclear axis and below the internuclear axis, thus forming a pi bond. It is just an electron cloud present. So children, by looking at all these structures, we can just say that the sigma bond is stronger bond and a pi bond is a weaker bond, and we can decide the structures of the molecules. But looking at different molecules, mainly beryllium chloride if you consider, then the sp orbitals in beryllium chloride, they overlap with each other, and the structure which was expected to form was not seen in beryllium chloride. And so they came to a different conclusion. Let us see this example, children. Formation of beryllium chloride. What is the atomic number of beryllium, children? It is 4, and the electronic configuration of beryllium is 1s2, 2s2. Here the p orbital of beryllium is not having any electron, so it is 2p0. It does not have any kind of unpaired electron. Then how is this beryllium chloride formed? It is expected to form covalent bond, but it forms two covalent bonds. How? Here actually what happens is the 2s orbital and the empty 2p orbital, they combine with each other. Here let us see what is this beryllium atom. It has 2 electrons in the first orbit and only 2 electrons in the second orbit. And so these 2 electrons are actually present in 2s orbital. But it is forming a double bond, one single bond with one chlorine atom and one other single bond with another chlorine atom. Then how is it possible? So there came a theory. So children, how is this beryllium chloride formed? The bond angle of beryllium chloride was observed as 180 degrees. So how is this possible? And there comes the topic hybridization. It was proposed by Linus Pauling. According to Linus Pauling, here the s orbital and the p orbital of beryllium atom, they overlap with each other, forming a hybridized orbital. So the concept here we are going to start is hybridization. So children, the bond angle between the beryllium and chlorine, 2 chlorine atoms here is 180 degrees. This is due to the hybridization. What is hybridization? It is a phenomenon of intermixing of atomic orbitals of almost equal energies which are present in the outer shells of atoms, and the reshuffling or redistribution into the same number of orbitals but with equal properties like energy and shape. Hybridization is of 3 types, children. So children, about hybridization we will be learning in the next class. So as we know that we have s orbital, p orbital and d orbital. So the orbitals, they overlap with each other and they combine with each other and they form a hybridized orbital. So there are mainly 3 types of hybridized orbitals you have to study. We will be studying it about it in the next class. So let us rewind what we have studied, children. A chemical bond that formed by sharing of valence electrons between the atoms so that both of them attain octet configuration or duplet configuration in the valence shell is called as a covalent bond. So a covalent bond is formed due to the sharing of electrons. Each shared pair of electrons is equivalent to one covalent bond, and electrons are not always shared equally between the atoms in a covalent bond, and this leads to bond polarity. To explain the bond angles in the molecules through the covalent bonds, the Valencial electron pair theory was proposed. So about Valencial electron pair theory, we will be studying it in the next class, and in this theory only we will be studying about the hybridization of the orbitals. Please answer this question, children. Draw simple diagrams to show that electrons are arranged in following covalent molecules. Draw calcium oxide, water and chlorine structures. What is hybridization, children? Explain the formation of following molecules, BeCl2 and BF3. How Lewis dot structures help in understanding the bond formation between the atoms. And explain nitrogen molecule formation and oxygen molecule formation by using valence bond theory. Please download the worksheets from a SIET website for better learning and good practice. I hope you have understood the lesson, children. Let us learn about hybridization in the next class. Thank you.